Group 4's Cantilever Beam Project, a freshwater project to determine the amounts of sediment suspended in water and the stiffness properties of metal beams. Beams follow a very specific model for how they behave under a specific load, and it can be represented by the following variables. K is the stiffness of the beam, C is a unitless constant, E is the modulus of elasticity, W is the width, T is the thickness, L is the length, M, N, P, and Q are all unitless exponents that remain constant. To determine these variables, we tested 22 different beams with at least 3 different loads to see the resulting deflection and the amount of load we put on. These are our results from those experiments. We graphed the resulting data and used MATLAB to determine the slope of the trend lines for each equation. This graph shows the resulting data of 7 of the 22 beams. We used that data to come up with a universal formula for beam stiffness. This graph shows how stiffness is affected by the width of each beam. To derive the equation, we rearranged the equation and solved for the variable c. The value n came from the slope of the line on the graph. After doing these calculations, we were able to determine that the exponent m has a value of 1, the exponent of n also has a value of 1, the exponent p has a value of 3, q has a value of -3, and the constant c is a value of 0.21. These tables show that the value predicted by our code for the deflection was only 4.2% off for a specific load applied and 2.3% off from predicting the mass at the end of the beam. The following criteria are the constraints that had to be met. The first one was only 3 instruments may be mounted on the end of any one beam. The second one was that the cost must be minimized. The third was that the deflection of the beam could be no greater than 1 inch. The best beams for the job were one 18-inch aluminum beam and one 18-inch stainless steel beam turned sideways to lower the moment of inertia. The $4 beam could not be used because even with the lowest weighted instrument on the end, the deflection was still greater than 1 inch. The next cheapest way to do it was to use two $10 beams.